Hassler here. Just going to give you some notes on 3.8 derivatives of inverse trig functions. Okay, so recall that an inverse trig function is written as y equals inverse sine of x or y equals arc sine of x. The same can be said about the other 5 trig functions. So cosine with that -1 of x would be read as inverse cosine of x or arc cosine of x, inverse tangent of x or arc tangent of x, etc. Also recall, so those two things are the same, right? That inverse sine of x is the same as saying arc sine of x, okay? And just a reminder, when you go to evaluate inverse trig functions, just like with regular inverse functions, the x and y get switched for inverse functions. Same with inverse trig functions. So if you're looking at the unit circle, and I'm actually just going to move my page. I'll move my page down here. Okay, so if I'm looking at the unit circle, and let's say that I'm looking at pi 6 right here, which has the ordered pair square root of 3 over 2 comma 1/2, okay? And if I say, what is sine of pi 6? We would say, oh, sine of pi 6, that's the y-coordinate, would be 1/2. Well, then if I were to say, what's inverse sine of 1/2? Remember, with inverse functions, you're switching the x and the y. And when we talk about the x and the y with trig functions, what we're really saying is you're switching the input and the output. So the input for the sine function in the first example is pi 6. The output is 1/2. Inverse sine, when we switch the input and output, inverse sine of half becomes the input. The output then would be the angle measure. So something to think about with inverse trig functions, okay? The input is the coordinate on the unit circle, and the output is the angle measure. So something that you have to consider when you go to work through some of these problems, okay? Always something to consider, right? Okay, so let me give you the derivative of these inverse trig functions. And again, these are just things that you're going to have to memorize. And so if I'm going to take the derivative of inverse sine, that would be the same as saying, let's take the derivative of arc sine of x, okay? These two things mean the same thing. That derivative is going to be 1 divided by the square root of 1 minus x squared. And the nice thing is that the derivative of inverse cosine, or again, the derivative d dx of arc cosine of x, those two things represent the same thing, is just the opposite or the negative of 1 divided by the square root of 1 minus x squared. So the negative of the derivative of inverse sine, okay? Or derivative of arc cosine of x, same thing, -1 divided by square root of 1 minus x squared. All right, we could play the same game for the derivative of inverse tangent. And that's the same as saying the derivative of arc tangent of x. Okay, those two things mean the same thing. And that derivative is a little bit different. It's still 1 divided by, there's no square root though, it's just 1 plus x squared, okay? I am not going to share the derivatives of the other inverse trig functions, the remaining 3, inverse secant, inverse cosecant, and inverse cotangent. If you're curious about what they are, you are welcome to look them up. I'm not going to be assessing you on them. I do not often see any problems on AP related to those 3. And so I'm not going to expose you to those 3. But like I said, if you are curious, you're welcome to look at them. I'm going to do just a couple problems, and then your job will be to try the other ones and turn this in on Classroom. So the first example that I'm going to do is number 1. It says find the derivative and simplify if possible. I have y equals inverse sine of 3x. And the first thing I ask myself is, how many functions do I see? And I actually see two functions. I see inverse sine of x, and I see the 3x inside of that. And so because I see the 3x. Because I see two functions, I must take two derivatives, and I must do that in the right order. So y prime equals, I have to take the derivative of the outside function. And up above that is 1 divided by the square root of 1 minus x squared. But in place of x, I'm going to write what was inside. And I have to put that in parentheses. I'm replacing the x. That means that both the 3 and the x are going to be squared. I also have to take the derivative of 3x. The derivative of 3x is 3. So I'm going to multiply that by the derivative of inverse sine. It says simplify if possible, and I can. 1 times 3 is 3. Divided by the square root of 1 minus 3x squared means I square the 3, that's 9, and I square the x squared. And that is it. That is all the further I can go in terms of simplifying. So your job is going to be to try 2 and 3 as part of your turning it in. I'm going to come down and I'm going to do 5. I'm not doing 4 because I just did an inverse sine. I'm going to do 5 so you can see an inverse tangent. And this one's slightly different. I'm given this function, and after I find the derivative of this function, I'm going to evaluate for the specific x value. Okay, so first I'm going to find the derivative. So f prime of x equals, I see two functions here. Again, I see the inverse tangent function, and inside of that I see the 4x. And so because I see two functions, I must take two derivatives, and I must take them in the right order. So the derivative of inverse tangent, that's the outside function, I'm going to do that derivative first, is 1 divided by 1 plus x squared. But in place of x, I'm going to write what was inside, which is the 4x. I'm going to multiply by the derivative of the inside, which is 4. And I can clean this up. 1 times 4 is 4. Divided by 1 plus, again, I have to square the 4, that's 16, and square the x, that's x squared. And then I'm going to evaluate when x is half. So I've got 4 divided by 1 plus 16, replacing the x with half squared. All right, now when I square a fraction, I actually square both parts of that fraction. So I'm going to square the 1 and the 2. This leads me to have 4 divided by 1 plus 16 times 1/4. 16 times 1/4 is 4. 4 plus 1 is 5. And so I'm struggling to write that 5. I really get that f prime of 1/2 is equal to 4/5. That would be my final answer. All right, I'm going to get you set up on 6, and then I want you guys to finish 6. And so the thing here with 6 is this is a limit definition of a derivative. This is the limit as h approaches 0 of arc sine of a plus h minus arc sine of a all over h. And I'm telling you what this is equal to. This is equal to 2. So I'm not asking you to evaluate at a specific a value. I am telling you that you're going to have to find what that specific a value is. So again, when I see this notation of the limit as h approaches 0 of this difference quotient, that tells me that I need to pick out the function. And the function would be arc sine of x. That I need to take the derivative of that function. And up above, again, that was 1 divided by the square root of 1 minus x squared. But this time, again, instead of saying that the a value is known, I don't know the a value. It just says a in my difference quotient. I'm telling you that I know what y prime is. Y prime is equal to 2. And your job now is going to be to solve for x, which means you have to do some algebra to figure out what that x value is going to be. And then you're going to circle the correct answer. Okay, so your job is to finish this document, upload this document, or turn this document in on Classroom, and then we will actually go over the answers tomorrow. So be ready to ask any questions that you have. You are also now ready to complete all the problems in the Pear Deck. All right, see you soon.